Have you ever stopped to think that the floor beneath your feet could be, well, an active line of defense against germs? Today, we're diving into antibacterial ceramic tiles. It's where some really sophisticated material science is hiding in plain sight. Let's get into it.
So think about it. We scrub our surfaces to get them clean, right? But the second we stop, the microbes, they just start coming back. So what if that tile wasn't just a passive surface? What if it was an active participant in staying hygienic? And that's really the core of the problem. On just an ordinary, unprotected surface, bacteria can multiply at a frankly staggering rate. A single cell can become millions in just a matter of hours. This is why a surface that looks clean is often anything but.
And look, this isn't just about having a sparkling kitchen at home. We're talking about places like hospitals, labs, and super busy public transit stations. In these high-traffic zones, controlling microbial growth is a serious public health issue. The ultimate goal here is to slash infection rates and create safer environments for all of us, especially in those critical areas where the risk of contamination is the highest.
So, how on earth do you turn a simple piece of ceramic into a microbe-killing machine? Well, it all comes down to some seriously clever chemistry that's integrated directly into the tile surface. Let's check out the two main ways they do it.
All right, the first strategy is called metal ion release. You could think of this as always-on protection. It uses ions from metals like silver or zinc, which are natural bacteria killers, and they work 24/7, light or dark. The second approach is photocatalytic action, and this one is light-activated. It uses a compound, usually titanium dioxide, that basically becomes a microbe-destroying powerhouse when it's exposed to UV light. So you've got these two really distinct philosophies, a constant passive defense versus a powerful light-triggered offense. Now what's so fascinating is how the silver ion technology works. It's not just one thing, it's a multi-pronged attack. First, the silver ions literally puncture the bacterium's cell wall. Once they're inside, they mess up its ability to breathe and completely scramble its DNA, which means it can't reproduce. It's basically a complete system failure for the cell. And what about photocatalysis? Oh, it's just as brutal and just as effective. When UV light hits the titanium dioxide baked into the tile's glaze, it creates these super powerful oxidizing agents. You can think of these molecules as microscopic wrecking balls that just tear apart any organic matter they touch. We're talking bacteria, viruses, even pollutants in the air.
Now, all of this sounds fantastic in a lab, but actually getting this tech into a mass-produced tile, that is a huge engineering feat. You're not just adding a simple coating, you're fundamentally changing the material itself.
And this visual really gets to the heart of the challenge. These incredibly delicate antimicrobial compounds, whether we're talking about silver ions or tiny TiO2 nanoparticles, they have to be mixed into the tile's glaze and then somehow survive an unbelievably harsh manufacturing process.
1,200 degrees Celsius. Let that sink in. That's over 2,000 degrees Fahrenheit. It's hot enough to melt many metals. And these active ingredients, they have to endure that inferno without breaking down or losing their antimicrobial power. It's just wild.
Okay, let's just walk through the process so you can see where this all fits. First, the raw materials are mixed and pressed into a tile shape. Then comes the critical step. The special antimicrobial glaze is applied. Then the whole thing goes into the kiln for firing. That final, fiery step is what fuses the glaze to the tile body, creating a single, incredibly tough, and now functional surface.
So here's the bottom line. The crucial challenge is this. You have to achieve that powerful antibacterial performance, but you also have to make sure the final product is still a high-quality tile. It can't mess with the color, it can't weaken the glaze, and it absolutely must resist stains and chemicals just like a normal tile would. It is an incredibly delicate balancing act. So after conquering this incredible tightrope walk of chemistry and extreme heat, the engineers faced the final and most important question: did it actually work? I mean, all this science is impressive, but how do we prove that a tile is antibacterial in a way that's measurable and repeatable?
Well, scientists use a key metric, and it's called the bacterial reduction rate. It's pretty straightforward. They put bacteria on a treated tile and on a regular tile, they wait 24 hours, and then they measure the difference. This gives them a clear, quantifiable percentage of just how effective that surface really is. And in the lab, you can actually see the results. This quote here explains how researchers can observe it with their own eyes. They measure what they call clear zones around samples of the active material. These are literally areas where bacteria simply cannot grow. It's a direct, visual confirmation that the tech is doing its job.
And the results? They're often this dramatic. A 99.9% reduction in bacteria.
To put that in perspective, for every 1,000 bacteria you'd find on an untreated surface, only one would survive on one of these high-performance tiles. That's an incredibly effective solution.
So what does all this mean when we zoom out and look at the big picture? It means these innovations are quietly making our shared spaces safer and more hygienic. We're literally building a healthier world, from the ground up.
And the real-world payoff is immense. For a hospital, we're talking about lower infection rates and safer outcomes for patients. For a business, it means lower cleaning costs and a more durable surface that lasts longer. And the long-term value is definitely there. Studies show that for healthcare facilities, the investment in these tiles can actually pay for itself in just 5 to 7 years through all those savings. It's a win-win.
It really makes you think, doesn't it? We've taken one of the oldest building materials known to humankind and embedded it with cutting-edge technology. So if our floors and our walls can actively protect us, just imagine what other everyday surfaces are on the horizon.